Okay, guys. So here in the last video, I'm going over the remaining problems. So many problems are repeating. They're asking for the same thing. So on page 828, number 17, you have to factor out GCF. You have 4p plus 12. The GCF between 4 and 12, it's 4. So you're factoring 4 out. And in the parenthesis, to undo factoring, you're just doing the division. In the parenthesis, it's going to be the opposite of multiplication, which is division. You take your original expression, which is 4p, and you divide by GCF, and we end up with p. That's why you see p inside of the parenthesis. And then you take the second original expression, which is 12, and you divide by GCF, which is 4, and we end up with 3. The next problem of the review was the problem from page 828, number 47. They also asking you to factoring out the GCF. So we have the expression 13 times a plus 6 minus 4b times a plus 6. So what will be the GCF? The GCF will be the factor which repeats, which means in this case parenthesis which repeats, a plus 6. That's why I put a plus 6 in front. And then times, you open the new parentheses and you put in the leftover, which means if I factor a plus 6, okay, the remaining expression is 13. That's why in the second parenthesis you see the 13. And if we factor a plus 6, so what goes inside of the second parenthesis? The expression which was in front of a plus 6, which is negative 4b. That's why you see here negative 4b, and that's your final answer. Next problem of the review was problem from page 843, number 11. They asking you to factor 3n squared plus 13n plus 4. So this is definitely quadratic equation. So first what you always do, you always checking first if you can factor GCF. The GCF, okay, between those three expressions, 3n squared, 13n, and positive 4. There's no GCF, okay? There's no way that you can find the number which divides 3, 13, and 4. And so there's no GCF if we're talking about integers. There's also no GCF if we're talking about the variables, because 4 doesn't have n. So since we don't have a GCF, you take in this quadratic equation and you factoring using AC method. So A is equal 3, B is equal 13, C is equal 4. Okay, so what I'm doing, I'm looking for two integers, which by multiplication will give you A times C, which is 12. And the same two integers by addition has to give you B, which is 13. And 12 and 1 works, okay? Now, in this example, you have to remember that this is the case when A is not equal 1. So at the beginning, what you're doing, you're putting 3n in each parenthesis because A was equal to 3. So you have 3n in first parenthesis and you have 3n in the second parenthesis, plus the first integer which we find, which was 12. And in the second parenthesis, I'm putting the second integer, which is 1. After creating those two factors, next you're taking each factor and you're checking if your factor has GCF. If your factor has GCF, you're going to ignore that GCF. So you have 3n plus 12. The GCF between 3n and 12 is 3. So I factor out 3, and I will end up with binomial n plus 4. Since this is the algorithm, you're going to ignore the GCF, and you only keep n plus 4. The second factor, 3n plus 1, has no GCF, so you keep your original, which is 3n plus 1. So our final answer is n plus 4 times 3n plus 1. Next problem, was from page 472, number 21, when you have to solve equation using zero product. So you have x times 5x minus 1. This is what you want to have. You want to have a product between two factors. Why? Because you don't need to do anything. You don't need to factor. They already give you factored equation. So how are you going to solve it? You're going to take each factor and make it equal 0. So we're taking each factor and make it equal 0. So we have x equals 0, which is the first solution. And then you have 5x minus 1 equals 0. You're solving for x. And that will give you just x equal 1 over 5. So we have two nice solutions, x equals 0, x equal negative 1 over 5, and that's going to be our final answer. The solution set, it's 0 and 1 over 5. Next problem from the review was on page 828, number 18. Again, so much factoring in this section. They ask you to factor GCF between 3q and negative 15. The GCF between 3 and 15 is 3. So I factor GCF. This is your GCF. You put it in front of the parenthesis. And then in the parenthesis, you end up with q minus 5. And I'm showing work how you end up with q minus 5. You take the first expression, which is 3q. You divide by GCF, which is 3, and you're getting q. That's what you have in the parenthesis. And then you take original second expression, which is negative 15. You divide by GCF, which is 3. This is equal to negative 5, and that's what goes inside of the second parenthesis. So the final solution of 3q minus 15, it's 3 times q minus 5. Next example for review, it's from page 857, number 24, when you have to factor binomial 36 plus s to a second power. So what I did with this problem, I would rewrite 36 as 6 to a second power plus s to a second power. And this problem is from section 14.5. So when you guys have a sum of two perfect squares, okay, expression like this, you cannot factor. It's prime. Okay, so it was the formula. I mean, there's no formula. But in section 14.5, I mentioned that when you have a sum of two squares, you can't factor that. This is prime. So, sorry. Sum of two squares is always prime. Okay, so can't be factor. Note, I wrote down the note for you, but we also see one extra example of that. When you will have an opposite, which means a difference of two squares, you definitely can factor, which will be a minus b times a plus b. Okay? So if you will have a problem, 36 minus s to a second power, you can rewrite that 36 as 6 to a second power minus s to a second power. And your a is the number in front of exponent. And b, again, it's a number in front of the exponent. So the formula tells you a minus b. So we have 6 minus s times a plus b, so you will have 6 plus s. Okay, but that's a different type of problem. In originally, question 24 from page 857, they gave you 6 to a second power plus s to a second power, so this is prime. Next, it's the problem from the same page, 857, number 15. They ask you to factor the binomial x squared minus 36. So here, since you have a difference of two squares, so you definitely can apply to this formula right here. a squared minus b squared, something like that can always be factored using the formula a minus b times a plus b, okay? So to be able to factor that, you have to figure out what is a and b, okay? So 36 is the same as 6 to a second power. A, it's x, b, it's 6, okay? So what will be the final answer, how we can factor that? You're using the formula a minus b, which is x minus 6, times a plus b, which is x plus 6. So that's our final solution right here. Okay. Next one was problem from page 835, number 31. You have to factor completely quadratic equation. But look what happened with this quadratic equation. The coefficients, the expressions all over the place. So make sure that when you have a quadratic equation, which means x or any variable to a second power, you will rearrange them in form as ax squared plus bx plus c. And then you will use AC method to factor. So I rearrange them. I put x squared first, then negative 13x as a middle expression, and then negative 30 as the last one. So how are you going to factor? Factor using AC method. This is the easy case since a is equal 1. So to factor that, it's going to be x plus first integer times x plus second integer. So I'm showing work. A is equal 1, b is equal negative 13, c is equal negative 30. I multiply a times c, that gave me negative 30, and then I'm looking for two integers, which by multiplication gives you ac, and the same two integers by addition has to give you b. Like you guys see in this problem, negative 15 and positive 2 works. Okay, negative 15 times 2 will give you negative 30. Negative 15 plus 2 will give you negative 13. So when you have those integers, you just create your two factors, x plus first integer times x plus second integer. So in our case, it's x minus 15 times x plus 2. And that's it. That was the last problem from the review. Okay, guys, good luck during the test. Hopefully the review helps you. The video helps you to study for a test.